right, go and take your homework out if you would, please. Page 26 in your textbooks. And asked you to do number 2 and 4. Asked you to do problems having not practiced at all in class. All you've done was watch me work them. So I understand if the results were not great, but having tried it last night, assuming you did your best, as I go over them now, I think the questions you had last night will begin to clear up. And I'm curious if maybe some of you got them right anyway. Let's go and start with number 2. You were given this relatively shallow triangle, given a hypotenuse of 3,500 meters, and 3,500 point meters, given a leg here of 1,311 meters. You were asked to solve for the missing side B, missing angle B, and missing angle A. Of course, we know angle C is 90 degrees. The first thing that I told you you'll want to do is to make an accurate diagram. Good news. I already gave you one. So step 2, class, is to set up a chart or table listing everything out. Let's start by listing our angles. Angle A, angle B, angle C. And then next to them, list the sides, A, B, and C. If you're neat and organized, it's going to make it easy to check your answers. Obviously, we already know angle C is 90 degrees. Now, that's infinitely 90 degrees, right? There's no sig figs to that because it's a right angle, infinitely 90. We also know side C is 3,500 point meters, and we know side A, 1,311 meters. So how many sig figs are we looking at in this particular problem class?
4.
They're wanting 4 significant figures here. Let's see. What's the first thing I should probably try to solve for? Again, we're only supposed to use given values. What's the first thing we may want to solve for here, Chris? Missing side B. You know 2 sides of a right triangle. If you're trying to find the third side, class, just use the Pythagorean Theorem. How many did that to find the missing side? All right. And when you used the Pythagorean Theorem, I think I have it written down here, to 4 sig figs, I got 3,245 meters. How many also got 3,245? Ethan, what did you have?
2,189.
Okay. So on your calculator, try it again. You got the 3,500 squared minus the 1,311 squared. And then equals, and don't forget to take the square root of the answer, and that's where we should get 3,245.19, blah, 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 blah. However, are we going to use that value to solve for anything else? No. So we don't need to put it in the memory because I'm not going to use it for anything. If I were, I'd save it, but I'm not going to put it on the picture, not going to do anything else with it, just leave it there for now. At this point, we have to solve for the angles. And maybe start with Quentin, angle A. With respect to the angle that we mark, and I told you mark the angle you're finding or the angle you know. Okay, if you know an angle, mark it. If you are finding an angle, mark it. And then mark the other things that you know. I know this side. I know this side. With respect to the angle that is marked, class, this is the hypotenuse and this is the opposite. And we need to think trig functions here. If I know the hypotenuse and the opposite, I should use the sine of theta. Sine of any angle, in this case angle A, is equal to the opposite, in this case 1311, over the hypotenuse, in this case 3,500. But what do I have to do to actually solve for the angle, to get just plain old angle A equals? Anyone?
First, you're going to have to divide 1311 by 3,500, then you're going to have to do the arc function.
Arc function. I'm going to have to take the arc sine of both sides. So we'll divide and take the arc sine, or depending on the calculator, you may take the arc sine first, and then divide out the quantities, 1311 divided by 3,500. And when we do, what do we get for our angle A? 21.9978, blah, blah, blah. How many sig figs? 4 still, because we didn't have any other sig figs to base this off of. If we had one of our angles given besides the defined 90, I'd round it that way, but I'm just going to cut it off at 4. But what does it round to?
22.
Yeah, the 7 bumps up to 10, bumps up to 10, bumps up to 2. So it's not just 22, but 22.00 degrees. Almost exactly a 22-degree angle here. Okay. Questions on angle A. Now, if you were really rushed for time, what would be a shortcut to get angle B?
Pythag.
Minus the 22 from the 90.
Subtract 90 to get to complementary angle. But if you screwed this up, you're now doomed to 2 wrong answers. So my recommendation is, unless you're really pressed for time, don't do that. Instead, we're done with angle A.
Does that happen a lot in this class? Like that?
I'd just like to mention it as an alternative. But we're now finding angle B. So we're not marking A anymore, now it's B. Well, with respect to B class, this is the adjacent, this is the hypotenuse, adjacent hypotenuse. We should be thinking cosine. Are you following along, Ethan?
I'm just trying to figure it out. Guys, I'm trying to figure out like how to do the square root and stuff.
It equals.
What?
Now, do the square root of the answer. So the square root of whatever the last answer was, that's what A and S stands
Sorry,
for.
I guess I'll
Gotcha. Okay, makes sense now?
Yes.
All right, no problem. So Ethan will help us with this one. We're finding the cosine of angle B, and we know cosine is 1 over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So in this case, what's the adjacent to B?
1,311
And the hypotenuse.
is 30,500.
And this time, to get angle B by itself, Ethan, I'm going to need to take the arc cosine of both sides. And Ethan, there's a couple ways you can enter. Now you guys will just do 1311 divided by 3500 equals, and then take arc cosine. Second function cosine, I'll spit it right out. For you, Ethan, probably the best way is to do second function cosine. That's what I was doing wrong. Second function cosine, parenthesis, and then do the 1311 divided by the 3500. And it equals. And I think I mistyped something.
Did you get 89?
I got 1.18, so that's definitely wrong. Second function cosine of
68.
1311 divided by 3500.
I got 68.002.
There we go, 68.0021, blah, blah, blah. And of course, cutting off at the fourth sig fig, rounds to 68.00 degrees. Now, as a check, we now can say, hey, these add up to 90. I'm pretty sure I did this right. But if you subtract it from 90, you now lost your ability to check. Also, one side is notably smaller than the others. One angle is notably smaller as well. So that makes sense. Your biggest side is the hypotenuse. That makes sense. All the numbers are as they should be. It checks out. Yeah, if you screw up on one of these problems, you'll screw up bad enough that those checks won't work. So you don't actually have to recalculate anything. All right? Did anyone happen to get these answers?
I got it, so if I didn't have 22.00 and...
You just had 22 and 68?
Right.
So you did it correctly. Good. Wow, that's great. All right, the rest of you maybe didn't get this, but you understand the process a little bit better now. Trying
I
it.
only had one angle wrong.
Oh wow, awesome.
Forgot to take the cofunction.
Forgot to take the, you mean the arc function, the inverse function? So you have some really weird little decimal answers here, okay, which you're like, something's not right, just inverse function. Okay, good. So we figured out what we did wrong. Excellent.
I had like 22.06 and 67.94, so kind of close.
So maybe somewhere a calculator entry error, possibly. Okay, let's take a look at the other one that you did for homework, and then we'll give you a chance to practice some others. Number 4, another really shallow, slivery little triangle, going the other direction this time. Given angle B, 72 degrees, given side BC, 111 centimeters. And so again, the sketch was given to us. So class, let's set up our chart. Or our table of given values and found values, all of our angles and all of our sides. Fill in the chart, of course, with everything you know. Of course, I know the 90-degree angle. I know a 72-degree angle. Notice that's 2 sig figs. And I also know, what is this side, class? It's little a, 111 centimeters. Doesn't hurt to label little a, little b, little c perhaps. I don't think that was done for you here, so doing that yourself is good. Easiest thing to find this time, class, to start out? The missing angle. All we have to do is subtract from 90 to get 18 degrees. And we're going to go there. But I'm not going to put it on the picture because I calculated this, and there's a chance maybe I screwed up. After all, Chris is the one who gave it. Just kidding. All right, so he got it right. Now, I need to find either side B or side C. Ethan?
Side B.
Side B. All right, so we're going to mark the side we're finding, and we're going to mark the other two things that I know. One of these will always be an angle. Either it'll be an angle we're finding, or we'll have a given angle. Always go to the angle first, whether it's what you're finding or what you're given. With respect to the angle class, I know the adjacent, and I'm finding the opposite. So opposite adjacent, tangent. So I should say that the tangent of any angle, in this case class, 72 degrees, is equal to the opposite, in this case,
X.
B, over the adjacent, 111. If I put this over 1 and I turn this trig ratio into a proportion, two ratios, I can easily see how to find B. Cross multiply. Strategy tip. Don't do tangent of 72 times 111, because you could accidentally multiply these and take the tangent of all of that. Do 111 times the tangent of 72. And we should get 3, 4, 1.6, blah, blah, blah. How many sig figs on the sides? 3. We did 2 on the angles, we'll do 3 on the sides, so we'll round B off to 342 centimeters. Don't forget your unit either. Now we're ready to go to letter C. So arrow to letter C. We ignore letter B now. Go back to the angle. With respect to the angle class, I know the adjacent, and finding the hypotenuse. What trig ratio? Cosine. I know the cosine of any angle, in this case a 72 degree angle is equal to the adjacent, 111 over the hypotenuse, C. Again, if we put this over 1, how do I solve for C?
72 divided by 111.
Alternate. Switch it up to where we've got the C is equal to the 111 divided by the cosine of 72. And when we do that, 359.20, blah, 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 blah. Which rounded off 359 centimeters. Once again, it's the biggest side, and it should be, but it's still smaller than if I added these two together. And my littlest side, by a long shot, goes across from an angle that's quite a bit smaller than all the others. Did you get the 359 now? Okay. Good to go on these. Anyone happen to get these answers? Quentin, you did. Excellent, okay. And did we figure out maybe what we did wrong in the homework last night?
I got the 72 and the 111.
I got the 18.
We got the 18 as well, but not.
Well, yeah, should have gotten the angle for sure. It's just getting the other there. All right, let's go ahead and practice some more of these. Number 1 presents an unusual challenge. You can maybe work right there in your textbook or copy it over into your spiral. The challenge, I suppose, of number 1 is that the angle they give you, class, is in degrees and minutes. Now, easy thing to do would be just convert that into decimal degrees for you guys. Ethan doesn't even have to do that. So let's go and convert that over to decimal degrees for those of you with a calculator that doesn't like those as well. And what is that in decimal degrees? Does it come out evenly, or are we going to have to do a memory?
35.25.
Now, here's the deal. 35.25 isn't bad. But is memory easier to enter? Maybe on your picture, instead of 35 degrees 15 minutes, instead of even 35.25 degrees, maybe you put this in the memory and you label the angle as memory 1. And that's angle A. And we're also given the hypotenuse is 850 feet. Of course, we know over here is side A. Of course, over down here is side B. And we're ready to set up our chart. Angle A, angle B, angle C. Little A, little B, little C. Now, we know the right angle, of course, is 90 degrees. Since they gave you angle A as 35 degrees 15 minutes, it would be ideal for you to find the answer in degrees, minutes, seconds as well. Nice thing is your calculator can do that for you. So you do 90 minus your memory, if you're you guys, not you, 90 minus the memory, and it'll give you what?
54.75.
Now, do you notice above your equal sign it says DD arrow DMS? Do second equal sign. and it'll convert it into degrees, minutes, seconds for you. What do we get?
54 minutes, 45 seconds.
64 degrees,
54.
54 degrees. Misheard you. 54 degrees, 45 minutes. Ethan, for you, you can literally do 90 degrees minus 35 degrees, 15, and it'll hit the degree button again, but your calculator knows what you mean. It should be able to hit equals. Try that on your calculator, see if it works.
54 degrees, 45.
Right, so it came out perfect for you as well. Excellent. All right. So even on the Casio, we're okay.
That's not all that.
All right.
It's not that.
Now then, we're ready to, well, let's write it on our missing side, our given side, excuse me, 850 feet for the hypotenuse. And let's see here. Jamie, which side do you want to go for?
A.
Side A? All right, so we're finding side A. I know this angle, it's in the memory, or Ethan, you've got the 35 degrees, 15 minutes, which you can enter easily enough. And I've got the hypotenuse. Which trig function, Jamie?
Sine.
Sine. And what should I write out, Jamie?
The sine of angle, memory 1, is equal to A over 850.
Perfect. The sine of memory 1 equals A over 850, or in Ethan's case, the sine of 35 degrees, 15 minutes equals A over over 850. Make it a proportion. How do I solve for A, Jamie?
You'll multiply the M1 times the 850.
Not the M1 times the 850, the
The
sine of
sine.
M1 times the 850. Go ahead and do that. And hold on, sine of 400 times 850. And I got her at 490.57, blah, blah, blah. Round it up. Let's see, is that an 850 point? It is just 850, so only 2 sig figs. 490 for side A. And don't forget the feet. Keep the same unit they gave us. All good on 490.57 blah? All right, next we need to solve for, now we've got an A, we need to solve for B. All right, Chris, what trig function?
Cosine.
Cosine. Adjacent hypotenuse, how do I write it out?
Sin.
Not, no,
Sine.
no,
No, cosine.
cosine.
M1 over 1 equals what is that? C? No, B.
B.
Over 850.
There we go. Cosine of memory 1, or 35 degrees, 15 minutes, equals B over 850. Once again, to solve for B, class, I need to cross multiply.
694.15.
694 point. All right, run into 2 sig figs. 690 feet. Let's see if these answers make sense. B is bigger than A by quite a bit. Is angle B bigger than angle A by quite a bit? Is side C still the biggest?
Yeah.
Yes. Is it still smaller than these two added together?
Yes.
All right, then it checks out. Questions on that? Feel like we're getting into a rhythm here?
Oh, yeah.
All right. Want you to do number 3. Put your seats to number 3.
By ourselves.
Allow yourselves. They don't use A, B, and C this time. They mix it up on you. PRS. All right, easiest thing to find is certainly missing angle S, class.
40 degrees.
40 degrees. And we're rounding to the tens place here because we're doing subtraction, right? And 90 minus 50, 40, but works out easily. Should have been good there. When it comes time to solve for side P, for instance, I'm solving for P. I know this. I know this. Which trig function, Quentin? Sine. And we know that the sine of, in this case, a 50-degree angle is equal to the opposite 120 over the hypotenuse P. Putting this over 1, how do I get the P by itself? Alternate. So that's going to be P is equal to 120 over the sine of 50. And we'll simply divide to get what for the side P, the hypotenuse? 156.64, blah, blah, blah. How many sig figs? 3 rounded off to? How many got 157 meters for side P, the hypotenuse? Okay, questions. Do we try to use the sine to get side P?
156 for.
156.6, blah, blah, blah.
Oh,
round
yes,
to
I did.
157.
Yes, I did.
Okay.
I did. I just had P and S like in different places.
Okay. And then looking for a side S, Chris, we're done with P. We're looking for S. What trig function? Tangent. And we'll say that the tangent of any angle, in this case 50 degrees, is equal to the opposite, which in this case is 120, over the adjacent, which in this case is S. Putting this over 1, how do I get S by itself?
Cross.
Nope.
Or alternate.
Alternate. And that'll give me S is equal to the 120 divided by the tangent of 50, and that should give us what for our answer?
100.6.
100.6, blah, 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 rounded to the 3 sig figs.
101.
I was asking Chris, but 101 meters is correct. The hypotenuse should be the biggest value, and that's true. The smallest angle, which by the way isn't smaller by much, isn't smaller by too much. And this is smaller than the two legs added together. All the numbers make sense. There we go. And it went perfect. Okay, questions? First chance to try it by yourself now that you have a little bit better knowledge. Question, Jamie?
So it doesn't matter since it'll be 3 simplest anyway. Either way, it doesn't matter. P and S don't have the decimal place at the end, or should we have it there?
Right here. No, you don't need to put a decimal if it's already got the 3. I'm lazy. Here you have to have, like, for one thing, they gave you the decimal, but like if we had found this one, we would need the decimal to make it have the 3rd sig fig. Yeah, good question. Any other questions? All right, drop down to number 7. Now you notice on number 7, there's no picture.
What?
Right? So we need to come up with our own picture. Now the easiest way to do this is if they give you an angle, but they don't always give you an angle. Did they on number 7?
Yeah.
What was the size of the angle?
SP is 23.
23 degrees. Now that's very small. It's smaller than 30, right? So remember how the 30, 60, 90 looks with that small angle at the top? We're going to have an even smaller angle at the top. So draw a triangle on your paper. And this is how it will usually be. Usually you'll have to provide your own sketch. And label the little bitty angle as 23 degrees. Again, it doesn't have to be measured, but here's the deal. Chris, as you put your hand down, if you make a big angle here, or like you put the 23 down here, your numbers aren't going to line up with your picture and it's going to confuse you. So as to reduce confusion, the recommendation is draw it so it looks right. Make the little angle 23 degrees. We also need to name the little angle class B. Because it says in the problem that angle B is the 23-degree angle. It's assumed, by the way, that the right angle is C in all of these exercises because they use A, B, and C, which means the unknown angle for now is A. That means opposite this side, this angle A is side A, the baseline will be B, and the hypotenuse will be C. One more thing that they give us.
Then I need to know.
Side A.
Well, I already have that marked. Side A is
25.0.
25.0 feet. All right. Questions on how to set up your own picture?
Can you stand up?
Sure. Questions on how to set up your own picture? All right, let's set up the chart. And fill in everything you know. Questions on setting up chart. Finish the problem at your seats.
question to ask you. I think I'm doing this wrong. Because my angle B can't be smaller than my angle A, right?
Your angle B can't be smaller than angle A?
Right.
Of course it can be.
Oh.
Angle A and angle B are complementary.
I mean, not angle, I mean,
Oh, side B. Well, of course it's going to be, because angle A is what?
oh, yeah, okay, I see. 67.
67. So in fact, angle B or side B is going to be quite a bit smaller because angle B is quite a bit smaller. So you're going to get a much smaller side for side B. All right, what do we get for side B, Ethan?
10.6 feet.
Good, 10.6 feet, which is a little less than half, right? Well, this is quite a bit smaller, so that makes sense. We get something very small. Now, I do know side C has to be the biggest, right? So it's got to be bigger than 25, but it's got to be smaller than like 35. So somewhere between 25 and 35. And what did you get for that, Jamie?
27.2 feet.
27.2 feet. You say, well, that's not much bigger. Well, notice, if you look at the picture, this isn't going to be a whole lot bigger than this anyway. So it makes sense at the 27.2. All the numbers work out. How many got it? Perfect.
Can you work out how to do the C, how to find C?
So you got side B, just didn't get side C. Yeah, absolutely. So we got this angle, finding the hypotenuse, given the adjacent. So adjacent hypotenuse is cosine. Did you try to use cosine?
I use tangent.
That's why. Yeah, not adjacent and opposite. That would be these two. You should have used tangent for B, right? But cosine for getting side C. So the cosine of 23 degrees is equal to the adjacent 25 over the hypotenuse C, and then we'll alternate. C equals 25 divided by cosine 23. All right. Give you just a minute. Got it now? All right. Let's do another one. Number 12. Number 12. Now this time there's no angle given. So you really just have to kind of just make a triangle and realize proportions and dimensions may not work out. My recommendation is just make it not a 45, 45, 90, but kind of just, but not extreme like this. See how this one has a really long leg and a really short leg? Make the legs a little closer to each other here and just call it whatever. But once you call it whatever, make sure you label correctly. So your side B, 36 miles, had better go across from your angle B. Your side C had better be the hypotenuse, 56 miles. Does that make sense? So when you're not given an angle, you don't really know how to draw the triangle perfectly, but just draw something. Make sure once you've labeled your A, B, and C, you put your sides in the right spots. Add your C's.
So this is a right triangle, right?
Yes, it is a right triangle, yeah. people finishing up. First thing we needed to find would be what, class? I would say definitely, if you got two sides already, just get the third side using Pythagorean Theorem. What does it round to, Quentin?
43 miles.
Rounds to 43 miles, and again, you ask yourself, does that make sense? Well, based on the fact that together they're now bigger than the hypotenuse, but each individually smaller, yes. Of course, we have a 90-degree angle here at C. Looks like we're going to go with 2 sig figs, which is presumably nearest whole angle. What did you get for angle A, Ethan?
I couldn't find A.
Couldn't find A. Okay, let's take a look at A then real quick together. If you're finding A, we know this side, we know this side. What trig function should we use to find A? I'm asking Ethan.
Just remember hypotenuse.
So,
Cosine.
cosine. So we'll say that the cosine of A, which I don't know, is the adjacent 36 over the hypotenuse 56. But that doesn't get A, that's cosine
I
A.
don't remember how to do that. So, arc cosine.
Right, take the arc cosine.
I can't remember how to do it.
Right, anytime you're finding an angle, you have to use those inverse trig functions. That's why writing this out, like as soon as I wrote it, it clicked, right? Take the time to write that out. What do we get for angle A?
49.9, but 50 degrees.
Right, we have to round it to 50 degrees technically for the second sig fig, and then in answer to Jamie's question of earlier, right? Okay, and then for angle B, again, we could cheat and say, well, if this is 50 class, this has got to be 40. But what if we messed that up, right? So maybe we switch and we say, okay, now we're going to focus on B, and what trig function would we need now, class? Sine. So we say the sine of B is equal to 36 over 56, and we take the arc sine, and it does come out to 40 degrees when we round. How many have this triangle perfect? Okay, and then Ethan, we just need to remember inverse functions. Quentin question. Same thing as Ethan. You're kind of like, I know it's cosine, but it's just coming out to this weird decimal, arc cosine. Anytime you need the angle, inverse function. Feel like we're getting there. Do 5 and 9 now. 5 and 9. 5 gives you a picture. 9, you're going to have to come up with your own. Bless you, I think. I'm not much. Yes, sir.
In an isosceles triangle, the complementary angles. Wait, no, there's no way it's an isosceles triangle.
It's not.
We had a triangle that was the exact same as number 12.
Sorry.
We had number 12, there's a triangle that had the exact same angles and everything, was it?
When you round, yes, they came out the same dimensions. It's not exactly similar, but they round the same. What do we get for the hypotenuse on number 5, class?
38 yards.
How much?
38 yards.
38 yards. How many had 38 yards for your rounded hypotenuse? All of you, excellent. And then we could find angle J to be how large? Someone else?
40.2.
Angle J
It's 50.
should be 50 degrees. 50 degrees. And angle K across from the 24 yards should have been the 40 degrees. Did you just write them backwards?
Yeah.
Okay, careful there. Be careful there. Make sure we think opposite. Because in both cases we're using tangent, right? So when we're finding J, that's saying the tangent of J is equal to opposite 29 over adjacent 24, and you're going to take the arctangent. But when it comes to K, it's still opposite adjacent, but it's the other way around. Tangent of K is opposite 24 over adjacent 29. And then you're going to take the arctangent. So literally you could get them backwards if you didn't look at them properly. So opposite adjacent, just be careful with that. Anyone perfect on 5? I continue working on 9. Continue working on 9.
I thought you said 12.
Not 5 and 9.
Yeah,
We already did 12.
I got it.
Yeah, that's why I thought, that's what I thought, yeah.
I don't know, I might have said 12, I'm sorry. I meant 9, 5 and 9, I wrote it. Don't know where my brain went.
It's good if I get some things done.
Except for that I do now. We finish 9, I'll come check. Yes, 2 sig figs. Of course, put little equal signs in between. Do number 8. When you finish, check your answers to number 9. The work is shown here. Once you have 9, go on and do 8. Quentin, are you good to go? Got all 3? All right, number 8. And then Chris, still working on it?
I didn't get that one right.
Okay. Do you see what I did?
Yeah.
Do you see what you did? Okay. Questions on why I did what I did? Go ahead and make sure you do it as well. Make sure you go through the steps and get the answers, and then you can go on to number 8. Notice at number 8, there are 2 legs of extremely different lengths. So make 2 legs of extremely different lengths.
You said number 8?
Number 8, once you finish, yes.
I'm getting the hang of this.
Good.
I'm starting to like this Casio.
Good. Well, as long as you get into a routine with it, that's the main thing.
I'm just scared of using another calculator now.
Mm-hmm.
It's way
Understandable.
different. It's way different.
So how you solve for C, of course, Pythagorean Theorem. How you solve for A, you're going to end up taking the arctangent of opposite over adjacent. And for B, you're going to end up taking the arctangent of opposite over adjacent. Should have found side C to be
48 inches.
48 inches. Should have found angle A to be 72 inches. And angle B, 18, or excuse me, not 72 inches, 72 degrees, and then 18 degrees for B. Extra credit for this evening. Page 26, number 10. Page 26, number 10. A couple other things to jot down. We will be finishing our material for these first 2 chapters in our lesson tomorrow. Friday, we will be reviewing over this material, and Monday, lesson 14 will be your first test over chapters 1 and 2. So lesson 14 on Monday will be your test. Finishing tomorrow, reviewing Friday, testing Monday. All right, you are dismissed. Have a wonderful rest of your day.